In this episode of the .NET 5 REST API tutorial, we will talk about secret management and health checks. We will see how to securely store secrets during development that your REST API can use easily as with any other piece of configuration. We will also learn about health checks and how they are a great way to report the health of our API. Today you will learn how to store and use secrets via the .NET Secret Manager, and how to use health checks to report the health of the REST API and its dependencies. So let's talk about secret management. As you know, at this point, we do have a REST API that is able to talk to a database, a MongoDB database. And in order to be able to talk to it, we have defined a configuration source where we have specified details like hosts and ports, so to be able to connect to that MongoDB database. The configuration source that we've been using so far is our app settings.json file, right? So we have host, localhost, and port 27017. But now we're going to enable authentication to the MongoDB database. So you're going to need a username and a password in order to be able to connect to it. And we have to tell our REST API how to use this information. So for the user, we're going to add our user, another user setting into app settings.json. We're going to call it just MongoDB admin for a username. And then we also have to specify a password. So should we just specify the password directly in the app settings.json file? Well, the answer is no. You don't want to add any sort of secrets into app settings.json or into any of the files that you have that are part of your service, right? So that's a basic good practice in terms of security. Never introduce secrets in there. If we cannot do this, then how are we going to pass that information into the service? So it turns to be that app settings.json is just one of the possible set of configuration sources that can feed into your REST API. There are other options, like you could use command line arguments, you could use environment variables, or you could even use a bunch of other cloud sources coming from the cloud that can provide configuration information into your REST API. In our case, we're going to use one that's called the Secret Manager. So this is just one more configuration source that's built into .NET, and that is already pre-configured for you for any new, brand new web API. And in that Secret Manager, we can securely store our password, let's say pass in this case, and without having to put that password within our REST API. So it's not going to be in any of the files that compose our REST API. It will be in some place in our machine, securely stored, but yet our REST API is not going to have any trouble reading that password, because just as anything else, it is coming just as a new piece of information from our configuration source, and that the REST API can easily consume. We are now going to enable authenticated access to our Mongo database. There are a couple of ways to do this, but to keep things simple, and since this is just a development database for learning purposes, we will delete the volume where our Mongo container currently stores all the data. This allows us to start a new container with a brand new Docker volume where authentication will be enabled. So the first thing that you may want to do is verify if you're running the container already or not. So what I'm going to do is open a new terminal, and I'm just going to do docker ps. That will tell you if you have the container running already, and you are indeed. In this case, I am. So the first thing that I have to do is just stop this container. So I'm going to do docker stop mongo. That stops the container. And now what I want to know is which is the volumes that I have available here. So docker volume ls, that will give us the one volume that we care about right now, MongoDB data. And now what I'm going to do is just delete it. So docker volume rm MongoDB data. So now the volume is gone, and we're free to restart the container with a brand new volume. So what I'm going to do now is just grab the initial set of the initial command to run the container, just as we did before. And as you can see, the same volume is here, but it's going to be a new one since we deleted it already. And what I'm going to do is just add a couple of environment variables that represent the username and password that are going to be used within the database. So if I just do -e and then specify the name of the variable, in this case it's going to be mongo init db root username, And here we specify the name for our user. You could use any name here. I'm going to use Mongo admin. So that goes for username. And now the password. For the password, you have to use Mongo initdb root password equals, and then you gotta pick a password. So I'll pick something here, not super strong, but still something like this. And finally, the name of the Docker image that we want to use. In this case, use Mongo. So with this, hit enter, and now we do have with Docker PS, we do have a database that has authentication enabled with a user of Mongo admin and a password of pass pound word 1. So at this point, our database requires authentication, but our service does not know about it yet. So what happens if we try to query data at this point? What I'm going to do is just hit F5 in the service. Okay. And then I'm going to Postman. I'll just try to query for items and see what happens. So these are items query, hit send, and yes. Command find failed, command find requires authentication, right? So, which is good. Authentication is working. It's just that our service does not know the correct credentials to talk to the database. So how can we make the service aware of the user and password it needs to use? So let's go back to VS Code. Let's stop and close this. And what I'm going to do is first I'm going to declare a configuration setting for the user. So I'm opening app settings JSON. And in this section where we have MongoDB settings, I'm just going to add one more section here for user. Let's call it user. And we know that the user we specify for the database is Mongo admin. Now, we also need a password. And of course, I could specify a password right here, but it's not a good idea. You should never specify secrets or confidential information in your app settings JSON file. That's a security, kind of a security hole. So you should not do that. Instead, we're going to take advantage of the .NET Secret Manager to store the password securely, and still we should be able to pull that secret into the service, into the REST API without any trouble. So to do that, again, I'm going to open a terminal. And here's what I'm going to do. First, let's initialize the secret manager for our project. And that we can do via .NET user secrets init. And if you take a quick peek into catalog csproc, you're going to see that there's a new entry there, user secrets ID. So this represents the identifier of this secrets configuration for this project. So from here on, we can start actually adding secrets for this project. And to add a secret, what you can do is .NET user secrets set. And here you have to specify the name of the secret. Now for the name, what we want to do is follow the convention of the settings, the settings property that we have defined already, and just add to it in the format accepted by .NET. So in our case, that means specifying MongoDB settings, and then we do colon, and then we specify the actual property that will represent the password. In this case, it's going to be just password. And after that, we specify the actual value, in this case for the password. And we know that the password is pass pound word 1. Word 1. Okay. So just like I did here, what I'm saying is that the name of this secret is going to start with MongoDB settings, which matches MongoDB settings right here. And password is one of the properties that is going to follow the other properties that we already have in the MongoDB settings class. And the actual value is pass pound word 1. Hit enter, and the secret has been added. What we need now is a way to read both the username, the user and the password into our service. To do that, we're going to go into our settings class, MongoDB settings. Perhaps I'll just close this. Let's add a couple of new properties here. So let's add string user and string password. So these are the two properties that will be populated at runtime by .NET into our app. Now, the other one that we want to specify is a modified connection string, because now it is not going to be enough to specify just host and port. We have to specify user and password. And the way that you do that for a MongoDB connection string is by saying user colon password, and then we'll say add host colon port. So that's the syntax that MongoDB is expecting from us. And so just by doing that, let's try querying again and see what happens. So I'll do F5 and I'll go to Postman now. So let's see if we can query for information, send. And yes, we don't get anything because remember, this is a brand new database because we modified the volume, but we are getting a 200 OK. So things seem to be running just fine. And just to be completely sure, what we're going to do is do a post. I'm switching to the post tab here and see if we can actually recreate this mega potion with price 45. And not just that, let me actually put a breakpoint over here and to see how these values look at runtime. Since this is a singleton, I'll have to stop and restart our service. So let's hit F5 again. And so the first time that the connection string is needed, we should hit this breakpoint. So I'll go to Postman and I'll do send here. And as expected, we have a breakpoint here. So as you can see, the user has been read from our app settings JSON file, and the password has been read from the secrets manager. So password is not at all written in app settings JSON, it's just coming from secrets manager. And really that magic that takes that password in here is being driven by program CS. When we do create default builder, that piece takes care of injecting the secrets manager as one more configuration source to our service. So you don't have to do anything special for that to happen. So if this happened and we just let it keep going, go back to Postman, and in fact, yeah, the mega potion has been created. If we query for them, we'll see that it is right there. So moving on to the next topic, let's now start talking about health checks and how to enable them. So, but first, let's learn about health checks. So as we know, we do have a REST API at this point that is talking to a MongoDB database. However, it is not uncommon to face issues as time goes by, right? So a REST API could go down for a bunch of reasons, or it could be actually intentional, right? We may be redeploying this REST API to our server, to our cloud service, or to our server, wherever it is going. So even if temporarily, that REST API could go down. And there could also be issues on the other side with talking to our database, right? So for any reason, that database, we may lose connection to the database, either temporarily or for a long time. Or something could be going on while we're talking to that database, right? So communication issues could happen. So with this, we may start getting questions like, is our REST API alive? So is it alive? Can we actually talk to this REST API, right? So you may start wondering this, or you may start wondering, well, can we reach a database? So is it there? Is that connection in a good state? And so, but really, what you're asking here is the broader question of, is it healthy? So is our REST API healthy? Is it ready to receive requests? Is it ready to do the job the right way? And to answer that question, the right way to do it is to enable what we call a health check endpoint. So you don't have to guess. So we will have you would have an actual endpoint that you can call. It's part of your REST API, and you can call to it, and it should be able to tell you if the service is healthy or not, right? And of course, there will be persons or people interested in that information. So you, as a developer, as an engineer that creates a service, may want to query for that help endpoint and see if the service is healthy. But really, the most important case, the most usual and traditional scenario is when you have an orchestrator system that will be in charge of knowing when your service is ready to receive requests. And we will talk more about this in a few episodes in the future, but having a health check endpoint is a key piece of any REST API that you have to think about right away. Now that we learned about health checks, let's see how we can enable them for our REST API. So the first thing that we have to do is to add the services for health checks, and that we can do within Startup CS. Before that, let's stop debugging and close terminal, and I'll open up Startup CS, and I'm going to head into the configure services method. So in that method, we're going to go all the way down, and we're going to add just one line here, services.add health checks. And now, so that adds the services, and now we need to add the middleware for it. And that we have to do inside the use endpoints method inside configure. So here we're going to say endpoints.map health checks. And then here you get to pick the route that you want to use for your health endpoint. So in my case, I'm going to go for health, but feel free to choose something else, like you could do something like HC, or you could do health C. It's really up to you what you want to use. I'll go for just health. And now I'm going to do F5, and let's try it out. So that should give us a very basic health check endpoint for our service. So back to Postman. And the way that you query for this health check is really very similar to what we do for the items route. So we just have to I'll open a new tab in Postman for the get verb. And I'll go for my localhost column 5001, and then you just add the your health route. In our case is health. I'll hit send, and here you get a result. It says healthy. So with that, you have a way to almost like ping your service to see if it's in a healthy state. So this means that, the service is up and running, and everything should be fine. However, this is actually not super useful, because even if the service is up and running, it means nothing if the database is down, right? So if the database is down, or if we cannot reach it, our service is not really that much healthy. So how can we tell if we have any dependent service like the database not in a healthy state? And how can we take advantage of health checks for this? So let me show you what we can do. So going back here, stop that, close this. What I'm going to do is add a NuGet package that's called ASP.NET Core Health Checks MongoDB. That will allow us to add a health check specifically designed to verify if MongoDB is running properly. So I'm just going to open a new terminal here, and I'm going to say .NET add package ASP.NET Core Health Checks MongoDB. So this is an open source project. It's not part of ASP.NET Core or .NET 5, but it's a very handy project. And with this package, let me show you what we can do. Close the terminal again, and then so here, what we want to do is add some options to this call to add health checks. But before we can do that, we need to pull out our MongoDB settings in such a way that we can reuse them later on. So to do that, I'm just going to grab this line here outside and into, let's say, here, and we will call this MongoDB settings. So now those MongoDB settings can be used over here for our MongoDB client singleton, but also for our purpose right now. After saying add health checks, we're going to say .add MongoDB, and here we will use MongoDB settings that connection string to specify the connection string that needs to be used to connect to the MongoDB database, right? So our health check is going to be based on can we reach this database or not. We will also add a couple of things here, like a name just to identify this specific health check, and we will just say MongoDB. And one more thing is a timeout. And this is because we don't want this health check to take a long while to tell us if the database is just down, right? So in this case, we'll say time span from seconds. Let's give it 3 seconds. If after 3 seconds we cannot connect to the database, we will consider that this has failed, right? The check has failed. So now that we did that, let's try it out. So I'll do F5. And let me actually remove this breakpoint and back into Postman. So here, yeah, I'm going to say health again, send, and it says healthy. And as expected, because our database is up and running. But if I go back into VS Code, into our terminal, and I just stop our MongoDB container. So let's see. Docker stop Mongo, that would stop our container, which is equivalent to just stopping completely our database, right? And the entire database service is just going down. So let's see what happens as I go back to Postman and I try to check for health. Will take like 3 seconds, and then yes, right here. So now health check is reporting as unhealthy, which is great, because now anytime the database is down, we can easily tell that as part of the health check that we're using right here. Now there's one more thing that we can use to improve this scenario, and it's the fact that we may want to have more than one endpoint to verify not just the fact that the service is up or not, but also if it is ready to receive requests or not. And the typical pattern here is to specify both a ready endpoint and a live endpoint. So our ready endpoint is going to tell us if we are ready to, well, if the service is ready to receive incoming request, right? Which in our case really means, so is the database up and running, ready to go, can we use it? While the live endpoint is just going to tell us if our service, just a service is up or not, is it alive or not. So to do these two endpoints, let's actually go back to VS Code. So I'll stop this again and back to startup. First thing that we have to do is going back to our health check configuration. We have to assign a tag to our health check. So let me show you what I mean. So I'll actually put these things down a bit so that we can tell it easier. So I'm going to open up one more line here, and I'll say tags. So I'll create a little array here, and here I'll say ready. So here I am attaching a tag that I'm calling ready, that will help me group every single health check for which I want to apply a ready endpoint. So the endpoint that specifies if I'm ready to start receiving requests. How do we use this? So now let's go back to our map health check section, and I'll add a line here. So now we need to specify our two endpoints, one for ready and one for live. So let's go for the ready one first. So instead of just having health here, I'm going to say, okay, so /ready. It's going to be a ready endpoint. And now I'll have to specify health check options. Let's see if I'm missing a namespace right there. Okay, so I'll open up this. And so at this point, we have to specify what we call the predicate. So the predicate is the way that you can filter out which health checks you want to include in this endpoint. So remember that right now we only have one, really, but that one has been tagged with ready. That's the one for MongoDB. So in the case of the ready endpoint, we want to include that MongoDB endpoint. So to do that, what you do is this. You say check, and then we'll say check tags contains, and then the tag name ready. And with that, you have a ready endpoint that will will only include those health checks that have been tagged with ready. And then we have to specify another endpoint. So I'm going to actually copy this. This one is going to be just live. And really, for the live case, we don't have to do much. We actually don't want to include any health check. We just want to say kind of the response of a ping, right? So in this case, we're saying just false. By doing that, we are excluding every single health check, including the MongoDB one, and so that it would just come back to us as long as the REST API is alive, as the service is alive. So that's the way that you can do the live. So ready will make sure that the database is ready to serve requests. Live is just going to make sure that our site, our service is up and running. So with this, let's run again. So I'll do F5. And I'm back into Postman. And this time, so let's see. So I'll query for, let's see, health live. See what we get. So it says healthy. It's expected because the service is up and running. Now I'll try ready. See what we get. So after about 3 seconds, we do get unhealthy. And this is because our database Docker container is still down, right? As we did before. If I go back here, and I go back to my terminal, let's say this one, and I'll actually restart the Docker container. So Docker run, yep, that should do it. So that starts the container again, go back to Postman, and he'll send, and I get healthy. Because the database server and the database are there up and running. And usually that's good enough. So that's what you want to do to enable your health checks. But if you happen to want a little bit of more information about the health checks that you have configured, you can actually customize the message that you're getting here. In this case, it's just a basic thing, healthy, but you can get more if you want to. And so let me show you how to do that. So back in VS Code, stop and close. We are going to look for our map health checks function. The ready one in particular is interesting. And what we can do is take advantage of what's called the response writer. This response writer you can use to specify how to render the message that you're getting as you're collecting the results of the health checks. So I'm going to say async context, oops, sorry for that, context report. Let's do this and then open curly braces. And then here I'm going to collect the result of the check. So for that I'm going to say result equals, I'm going to use this JSON serializer, the one that comes with .NET. I'm going to serialize. Now I'm going to create an anonymous type here. So I'll just say new, and then we have to give it a shape. So this is the shape of what we're going to return back into Postman to the color. So the first thing that I want to show is a status. Status we can get from report.status. I'll just do toString. And then we want to get the array of checks, which should include our MongoDB check. So in this case, I'm going to say report entries, select, and I'll say, so I'll project each entry into a new anonymous type. And in this type, I want to show first the name, which is going to come out of entry.key. Then I'll get the status of this very specific check, which is going to come from entry value status to string. And then there could be an exception coming from the database. So let's actually capture that too. Oops, sorry. Exception is going to be entry.value.exception. But we may or may not have an exception depending on the status of this check. So what we're going to say is that if the exception is not null, we will get entry value exception message. But if we don't have any exception, if it is null, we will just say none. Finally, one last detail could be interesting is the duration. That will tell us how long it took to do this health check. entry value duration to string. Okay, so I'll do this. And now one more thing that we can do here is to format that output. So I'm going to say context that response that content type equals media type names. I'm missing something, yeah. Dot application dot JSON. So that will let us render as a nice JSON string back in Postman. And finally, I'll actually write this information out. So await context response write async result. Yeah, missing one namespace there. And that should do it. So now we have customized how that message should be rendered. So I'm going to do F5 once again. And back into Postman. So let's see what happens when I try my ready endpoint now. So I hit send. And now, as you can see, the result is a bit nicer. So we do have a status of healthy, and then we can see the array of checks. In this case, we have MongoDB with a healthy state, no exception, and a duration in there. And if we wanted to get the sample with an actual exception, you can just stop your Docker container again. Docker stop Mongo. Container stopped. I'll try again back in Postman. Send. And after 3 seconds, we should get, yeah, so now, as you can see, the entire health check is unhealthy. Specifically, MongoDB is unhealthy. And yeah, the operation has been canceled. So that's what we're getting from trying to talk to MongoDB. Now, one last thing that I wanted to show you is that there's actually a bunch of health checks already available for you. And so just like we did the MongoDB one, let me stop and close this. If you remember, we did this here. We did the MongoDB one. Just like this, there's a bunch of other ones already available for you to try out, depending on the service that you're using. And let me point you to this page here, which is the page for the open source project that I mentioned that has these health checks. So over here in this GitHub project, you are going to see that, so this will tell you everything about how to use these health checks. But I wanted to show you that there's already health checks built in for a bunch of providers, right? So SQL Server, MySQL, a bunch of things, Cosmos DB, SendGrid, a few Azure services, Amazon services, Google stuff. Here's the one that we use, MongoDB. And so yeah, so there's a bunch of providers already available. And there's even, and here's a NuGet package that you can use. And there's even support for, let me show you, there's support for a UI. I don't usually use this one, but if you wanted to show a very nice UI with all your health checks, with a breakdown for each of the checks, you can actually enable this health check UI. Sorry. And that will just stand up another endpoint in your service that you can go to and get all this nice UI being rendered. So that's something that you may want to try it out. I usually find there's some other ways that I query for the health of my services, as we're going to see as we move forward with these videos. But this is another option that you can try. So once again, thanks a lot for watching this video. And as I said before, if you are liking these videos, please consider hitting the like button. And if you want to know of any new videos that I put out, consider hitting that subscribe button. And yeah, so thanks for watching, and I'll see you next time.